In order to explain the concept of hybridization, we can use a small bowl and these balloons. This can be considered as one s orbital. This is px orbital. This is py orbital. And this one as the pz orbital. So in sp3 hybridization, we are mixing one s orbital and 3 p orbitals. As a result, we get hybridized orbitals. What about the shapes of these hybridized orbitals? As you all know, we get 4 hybridized orbitals. In sp3 hybridization, we mix one s orbital and 3 p orbitals. We get 4 hybridized orbitals. We get 4 sp3 hybridized orbitals. And these are the 4 sp3 hybridized orbitals we have. In order to show their orientation in space, we can do a small process, that is, we'll be tying all these balloons together. When these 4 balloons are tied together in space, see its orientation. It is oriented in a tetrahedral manner. It is oriented in a tetrahedral manner. And as you all know, in sp3 hybridization, the shape of the molecule is tetrahedral. The bond angle is also, as you all know, you can see that it is 109 degree 28 minutes. For example, in methane, if you see, this point represents carbon atom and all these 4 balloons represent carbon-hydrogen bonds. These are the 3 hybrid orbitals we get in sp2 hybridization. When we mix 1 s and 2 p orbitals, we get 3 sp2 hybridized orbitals. In order to show their orientation in space, again we are tying these 3 balloons together. This is the orientation of the hybridized orbitals in sp2 hybridization. Bond angle we can show, here it is 120 degree. Next is sp hybridization. After mixing 1 s and 1 p orbital, we get 2 sp hybridized orbitals. This is the orientation of the 2 sp hybridized orbitals in space. These 2 orbitals are oriented in a linear fashion with a bond angle 180 degree. This is what is sp3 dehybridization is. These 3 are sp3 dehybridized orbitals oriented in one plane. These 2 are the other 2 orbitals, sp3 dehybridized orbitals, which are in the other plane. This orbital is above the plane, this is below the plane, and these 3 are in the same plane forming equatorial bonds, and these 2 form axial bonds. This is sp3d2 hybridization, where 4 sp3d2 hybrid orbitals are in one plane and the other 2 are in the other plane. One above the plane, other below the plane. The shape of the molecule you can easily show as octahedral. And the bond angle here is 90. This is the orientation of the 6 sp3d2 hybridized orbitals in space. The 4 sp3d2 hybridized orbitals are oriented in one plane and the other 2 sp3d2 hybridized orbitals are oriented in the other plane. One above the plane, other one below the plane. So this is the orientation of the hybridized orbitals in sp3d2 hybridization.